Our group was assigned Chapter 22, which is about substituted hydrocarbons. The title of our presentation is Substituted Hydrocarbons from Alcohols to Esters, a Complete Guide.
In Chapter 22.1, it talks about alcohols. Alcohols are substituted hydrocarbons that contain one or more hydroxyl units. Alcohols are derived from both unsaturated and saturated hydrocarbons by replacing a hydrogen atom with a hydroxyl group. Examples of alcohols include isopropyl alcohol, which is used in rubbing alcohol antiseptic, which is a form of hand sanitizer. In the preparation of alcohols, there are two methods. One of them is the hydration of alkenes, in which the alkaline reacts with water in the presence of hydronium ions that are furnished by the catalytic actions of sulfuric or phosphoric acid. Another way is the hydrolysis of halocarbons, in which halocarbons react with water solutions of strong hydroxides. Some uses of alcohols include the methanol, which is a colorless liquid used as fuel, ethanol, which is a colorless liquid and is the primary alcohol in alcoholic beverages or is otherwise seen nature to be manufactured, ethylene glycerol, which is used as an antifreeze in automobile radiators, and glycerol is a colorless, odorless, slow-flowing liquid used in making synthetic resins for paint and in cigarettes. In the picture, it shows the structural and molecular formula for ethanol.
Section 22.2 was all about halocarbons. Halocarbons are alkanes in which one or more halogen atoms, such as fluorine, chlorine, bromine, or iodine, are substituted for one or more hydrogen atoms in a hydrocarbon. They can be easily synthesized and converted to other compounds in the lab, and they're excellent solvents. An example of a halocarbon is dichlorodifluoromethane, which is CCl2F2. This is used as a refrigerant in mechanical refrigerators and as propellant in aerosol products. Halocarbons are prepared in three main ways. The first is through direct halogenation. This is when halogens react with alkanes. An example of this process is in the Friedel-Crafts reaction. The second is when alkenes and alkynes react with hydrogen halides. And the third is alcohols reacting with hydrogen halides. On the bottom right corner, you can see the structural formula for dichlorodifluoromethane. Uses of halocarbons. Halocarbons like carbon tetrachloride, CCl4, can be used for dry cleaning fabrics and removing grease from metals. Another important use of halocarbons is in freon halocarbons. An example of this is dichlorodifluoromethane, which was mentioned earlier. It is used as a refrigerant in fridges and air conditioners and as a propellant in aerosol. Tetrafluoroethane, C2F4, or Teflon, is a polymer that can form long chains, which makes a flexible substance that has a low coefficient of friction. This gives Teflon pans non-stick properties. Unfortunately, halocarbons have played a role in the depletion of the ozone layer, as is shown in the following video. Please pause the presentation now and watch the following video.
The next section is about ethers. An ether is a group of compounds in which two hydrocarbon groups are bonded to the same atom of oxygen. An example of an ether is diethyl ether, also called ethyl ether, and it is used in anesthetics. As you can see in the first diagram, these are some examples of ethers and their structures. To prepare ethers, there are two ways: dehydration of alcohol and Williams synthesis. Dehydration of alcohols is when an alcohol is heated with concentrated sulfuric acid to 140 degrees. Williams synthesis is when the reactants are the sodium salt of an alcohol and a halocarbon. It is used to prepare mixed ethers. As you can see in the second diagram, the R and R1 group are two alkyl groups, which are the hydrocarbons, and they may or may not be the same. When they are not the same, it is called a mixed ether. The uses of ethers are that they are used as solvents for many organic compounds, and they slow down the operation of the central nervous system, which is why they're used in anesthesia, and they are also used in gasoline to increase the octane rating.
Chapter 22.4 talks about aldehydes and ketones. Aldehydes are substituted hydrocarbons in which one or more hydrogens have been replaced with a carbonyl group where the carbon is bonded to at least one hydrogen. This is known as a formal carbonyl group. An example of an aldehyde is formaldehyde, which is used in the preservation of biological specimens and to create cleaning supplies. The preparation of aldehydes is through the oxidation of alcohols with a hydroxyl group bonded to the end carbon, and often has the help of a catalyst. Some uses are to provide natural flavors such as cinnamon, vanilla, almond, and lemon, to preserve biological specimens, and to make certain adhesives. In the bottom right-hand corner, you can see the structure of a basic aldehyde with the formal group and the structure of specifically formaldehyde. Ketones are substituted hydrocarbons in which one or more hydrogens have been replaced with a carbonyl group, where the central carbon is bonded to the carbons in two alkyl groups, which are two other carbon-based groups. An example is acetone, an active ingredient in nail polish remover. The preparation is through the oxidation of alcohols that do not have a hydroxyl group attached to the end carbon. Some uses are to provide natural flavors and to be used as a solvent. The bottom right-hand corner shows the structure of a carbonyl group, the carbonyl group in aldehydes, and the carbonyl group in ketones.
22.5 is about carboxylic acids. Carboxylic acids have a carbon atom bonded to an oxygen atom by a double bond into a hydroxyl group by a single bond, which is the carboxyl group. The fourth bond links to a carbon atom to a hydrocarbon group. Examples of carboxylic acids are acetic acid, which is vinegar, formic acid, and acylic acid. Carboxylic acids are prepared commonly for the oxidation of primary alcohols or for the oxidation of aldehydes. Commercially, they're prepared from the reaction of CO and the alcohol possessing fewer carbon atoms than the desired acid. The picture on the bottom right is the structural form of the carboxylic acid, where R is the hydrocarbon group. Carboxylic acids have many uses. Acetic acid is used in dyeing in textiles and production of cellulose acetate and synthetic fibers and solvent for organic compounds. Formic acid commonly occurs in ants and is an acidifying agent in the textile industry. Acylic acid occurs in plants such as rhubarb and sorrel. Also, it is found in urine and guano. Commercially, it is used in dyeing and calico printing and in laundry for the removal of stains and ink spots.
Section 22.6 talks about esters. Esters, which are similar to carboxylic acids except ethers, esters have an alkyl group in the place of hydrogen in the hydroxyl group. An example of esters is fat and oils, which is esters of glycerol, and ethyl acetate, which is an ester of acetic acid and ethanol, and is found in alcoholic beverages and used to decaffeinate tea and coffee. To prepare esters is used in a process known as esterification, where alcohol and an organic acid react to form an ester in water. The reaction usually takes place when there is an inorganic acid which acts as a catalyst for the reaction. Its main uses are to provide smells and flavors for perfumes and artificial flavorings, namely mostly fruity or floral smells, and as solvents for organic compounds.
Please stop the video here and complete the multiple choice quiz about the Google slide.
Please pause here to watch the instructional video, which is our second teaching method.
Please pause here to play the Kahoot.
In summary, there are 7 types of substituted hydrocarbons in which the one or more hydrogens are replaced with a different group. Alcohols have hydroxyl groups that replace the hydrogen. Halocarbons have a halogen that replaces the hydrogen. Ethers have 2 hydrocarbons bonded to 1 oxygen. Aldehyde has a formal carbonyl group, and ketones have a ketone carbonyl group. Carboxylic acids have a carboxyl group. Esters have a carboxyl group where 1 hydrogen is replaced with an alkyl group. They have many uses in daily life and are common ingredients in things that we use in our everyday lives. Here is our works cited page.